Hello everyone, my name is Shailee, and for the last 6 weeks I have been working at RBB Economics. RBB Economics is an economics consultancy firm. They have offices around the world, but mainly in Europe, and they specialize in competition law and have undertaken cases in various countries, shown by all the green in this map. So at RBB, the team consists of economists and econometricians who use technical economic skills to deliver analysis. And some econometric approaches are built on linear models. So the question for RBB was, can machine learning or data science add anything of value to the type of work that they currently do? We will come back to that question at the end of this talk. So my project concerned the music industry. The music industry, it seems, has been continually disrupted over time, more recently with a move away from physical CDs to digital listening and viewing options on our smartphones, tablets, and computers. In light of all of this, RBB's client, one of the biggest music video platforms where people can go and watch music videos for free, wanted to understand the impact of its service on other audio streaming services. Essentially, this question revolves around these two effects. Is it a positive promotional effect, or is it a negative cannibalization effect? In other words, if more people watch a music video on this music video platform, does this lead to more streams or less streams for audio streaming services? To answer this question in terms of data set, I had weekly number of views and weekly number of streams for roughly 3,000 songs from each of these 4 countries: the UK, Germany, France, and Italy. The streams data spanned for around 2.5 years, and as you can see, the number of streams per week were quite significant. France was an exception in the sense that we started getting data about a year later. So I used a random forest regressor for my analysis, and this is because I specifically wanted to move away from making the types of assumptions that econometric linear models make. So in terms of data, I then go on to split my data in training and testing sets. So for each song, I use the first 80% for training and the 20% for testing. Moving on to model building. So I first built a random forest model using past streams values only, controlling for any variations that are due to the streams themselves, any inherent characteristics of the song, and any information about the different weeks. The model will then go on to predict the number of streams on the 20% test set. Then I add views information to my model and compare performances. I can go a step further and actually compare models using added views information in the current week, or added views information from 1 week ago, or added views information 2 weeks ago. So what did I find? So on this slide, I've tried to illustrate my results. So the green dashed line represents the model performance by the model that doesn't use any views information, and you can see that the models that have views information added to them perform better. Interestingly, for UK, Germany, and Italy, the best performing random forest model was the one that used views information from 1 week ago. For France, it was the model that used information about views in the current week. But what does this all mean? It means that if you want to predict the number of streams on a music video, on a song, then the number of music video views is a statistically significant predictor. This indicates a small promotional effect by the music video platform on audio streaming services. This was also the conclusion reached by RBB using linear models. But this time, because I have used a random forest, which makes no such linear assumption about the relationships in the data, their conclusions and analysis are now stronger. To summarize, coming back to RBB's question of whether machine learning or data science can add any value to what they already do, the answer to that question is yes, and I have demonstrated that by working on this project. And as a result of my work, their analysis and conclusions are now stronger. Thank you for listening.